Hi. First of all, I would like to say that I am very happy to show our work in building sustainability. Our presentation is called Beauchef Leadership in Sustainability and Energy Efficiency. Beauchef is a modern building that will increase by 50% the current infrastructure of the faculty, which now operates in 24 buildings spread over the neighborhood. The new building has about 50,000 square meters distributed over 7 floors on the surface and 6 underground, which will house classrooms, laboratories, offices, auditoriums, sport facilities, and parking. The building is located in an area of 6,500 square meters. The facade corresponds to a double glass wall that serves as a thermal insulator, which decreases the entry of solar radiation, fundamental to sustainable architecture. The construction features a large central square from which you can access to various facilities. The east and west of this will rise 2 towers of 7 floors each, in which the academic activities will be developed. In contrast, the south side of the square has an audience of 536 square meters will be highlighted with a capacity of 200 people and emulate the form of an insect. This volume is raised above the central square. Underground, there will be spaces dedicated to sports. In the first 3 levels of underground, 2 sport fields, a swimming pool and a gym are designed. The lower floors, from 4th to 6th underground, will house 450 parking spaces. In this ground, we'll highlight a staircase with a spiral, which emerged as a large sculpture from the third underground to the surface of the central square. Goals in sustainability and environment. From the point of view of architectural design, we're giving priority to the main orientation of the building and its grounds. In terms of materials, it was privileged the use of systems and materials that do not require long transports or cause substantial damage to the environment. Related to goals in energy efficiency, lighting systems and more efficient air conditioning available in the market were considered. In this point, systems identified are monitored and operated from central control systems that optimizes efficiency during operation of the building. The artificial lighting system of the building is complemented by the contributions of natural lighting, so that decreases energy expenditure in addition to lowering the thermal loads considered in the HVAC sizing. Goals in indoor environment quality. For offices areas which represent the largest area of the building is expected to have an optimal indoor environment. To do this, ventilation systems ensure sufficient air renewal, properly filtered with proper humidity levels and thermal comfort were considered. Furthermore, the use of natural light and exterior views to the greatest possible number of operated premises was favored. Smoke is not permitted inside the building, so it has a smoking area provided outside it, far from the access and air intakes. Requirements for users and maintenance personnel. It is considered to conduct briefings for all personnel who will use the building, so they are familiar with the main architectural and design criteria and systems to be integrated into the building, and so contribute to its optimum operating concept. Additionally, will be trained in depth to the personnel responsible for the maintenance and operation of the building and other spaces to obtain the most efficient system performance. LEED certification. Through its various strategies of sustainability and energy efficiency, Beauchef is opting to get the level of LEED Gold certification under version 3. Following, these strategies are presented for each category and associated credit obtained. Sustainable site. The location of a project is the foundation of the sustainability of a single building or an entire neighborhood. The sustainability of a project has several aspects, transportation, selection, design and site management, stormwater management, among others. These elements include the interaction between the project and its local and regional circumstances, as well as their impacts on ecosystems and water resources. The most sustainable sites are those that can reduce transfer demand, restore degraded or contaminated spaces, minimize the impact of light pollution, and manage stormwater to protect water quality and aquatic ecosystems. The score attempted in this category is 21 of 26. Erosion and Sedimentation Control Plan. The project complies with the requirement of the credit to reduce pollution caused by activities associated with construction sites, controlling soil erosion, sedimentation, and airborne dust generation. This was achieved through the implementation of an erosion and sedimentation control plan during construction activities, which meets the requirements set forth in EPA Construction General Permit. The plan for pollution prevention consisted of the following: minimize the amount of land involved, prevent water runoff into the ground and odor, prevent the generation of airborne dust, take measures to contain soil, stabilize the soil, and additional measures. Access to bicycle parking, dressing rooms, and preferred parking for energy-efficient vehicles. The project promotes the use of alternative transportation such as bicycles and fuel-efficient vehicles. The project provides 120 secured bicycle parking and 56 dressing rooms with showers. Additionally, 24 preferred parking for low-emission vehicles and fuel-efficient is provided. Reduce heat island effect in non-roof and roof. The project complies with the requirements of the credit to reduce the heat island effect and the impact it has on microclimates and habitats. The project complies under option 2, which indicates that it must be located at least 50% of the parking spaces under cover. Beauchef Poniente has 450 underground parking in the 4th to 6th underground levels, which means that 10% of their parking spaces are located below deck, allowing eligible for exemplary behavior in this credit as required band. On roof. The project complies under option 1, which indicates the use of roofing materials with solar reflector index equal to or greater than 78, which must be used for at least 75% of the deck area. In this case, the project achieved 86% of the area. Reduce nighttime light pollution. The project minimizes the transmission of light from the building and site outdoors, reducing impact associated with lighting in night scenes. A monitoring system programmed is incorporated to keep off the lighting from 9 p.m. to 7 a.m. and activate the occupancy sensor for all non-emergency spaces in the building envelope. For outdoor lighting, a photometric study was conducted through LILUX program, which verifies that the power densities of the all exterior lights do not exceed the requirements specified in a trial standard for the area in which the project is located. Water efficiency. This category encourages and recognizes the efficiency measures that significantly reduce the amount of potable water used in the building, but always reaching the needs of the systems and the occupants. These measures address all water use associated with the building: indoor water for bath, water outdoor landscaping, water for industrial and building system purpose. The score attempted in this category is 6 to 10 scores points. Reduce water use at interior of Beauchef Poniente building. Beauchef Poniente achieves water savings in sanitary ware, bathroom and kitchen of 33% related to the consumption base that establishes the Energy Policy Act of 1992 for this type of event technology, as you can see in the following table. Reduce irrigation water. Beauchef Poniente reduces 10% the total potable water consumption for irrigation by using the following strategies: using native vegetation, Use native plant from the area and the region, which can survive drought conditions with low volume irrigation and maintenance. Irrigation systems. The irrigation system includes drip irrigation in all the green areas of the project and the irrigation controller with humidity sensors with an efficiency of 60%. Reuse of greywater. Collection system and reused greywater from showers and sinks can cover third underground water demand for irrigation remainder up to 10%. Energy and atmosphere. Energy has emerged as a critical and priority in the design of economic policy issues. Unsustainable patterns of energy supply and the high demand generated long-term impacts at all scales, both in the budget of the home and in international relations. The buildings are in the forefront of this issue, and integrated design buildings, neighborhood, and community design can put energy efficiency and benefit supplies cleaner and renewable energy. Efforts to address the energy issue focus on four interconnected elements: energy demand, energy efficiency, renewables, and energetic performance. The score attempted in this category is 16 points. Fundamental and enhanced commissioning. The bidding addresses all activities associated with the commissioning process, both fundamental and enhanced. Commissioning is a systematic process through which it aims to ensure that all energy-related building systems are installed, calibrated, and implemented in accordance with the design and operational requirements of the owner and the designer. All equipment and systems must be installed according to the manufacturer's recommendations and best practices in the industry standards. The fundamental systems that were commissioned in the building are HVAC systems, lighting system, and central control. Optimize energy performance. Usted caliente meets the prerequisite and credit since power consumption exceeds the minimum threshold required, corresponding to 10% to the consumption baseline described in a TRES standard. This energy efficiency has been addressed through the following strategies. Envelope. Thermopanel glass curtain wall with low emissivity and a double silk-screened skin gives shade and thus reduces the energy consumption for cooling. HVAC system. Efficient design for each building climate control area. Efficient lighting system. Artificial lighting includes the use of efficient lighting and a central control system based on the daylight sensor in offices and an occupancy sensor in hallways and parking lots, which results in an energy use reduction of approximately 50%. Central control. Lighting control system that allows the maximum use of natural light and efficient use of artificial lighting system. Using fluorescent luminaires equipped with digital dimmers, which allows reducing artificial lighting according to natural light conditions outside. In addition, the ability to adjust the level of illuminance on the wall surfaces in each area. Renewable energy. The proposed system consists in 44 solar collectors with a capture surface of 105 square meters. It's an active system that includes circulation pumps and controls. The system is installed on the roof of the building, facing north with an approximately 40 degrees of inclination. The systems generate 53% of annual demand. Materials and resource. Buildings generate a lot of waste throughout its life cycle, from construction and operation of the building until its demolition. However, the amount of waste leaving the property can be reduced through the implementation of recycle plants for the construction, operation, and demolition. When choosing materials and resources, the focus should be on the consequence and the consideration of health and productivity of the building occupants, as well as social, economic, and long-term environment impacts that the materials used in the construction of the building can produce. Green buildings addresses two problems related to materials and resources: waste management and life cycle impacts. The score attempted in this category is 7 points. Reduction and separation of recyclables and construction waste management. Reduction and separation of recyclables. The project provides an easily accessible area dedicated to the collection and storage of recyclables. The materials included in the recycle program are paper, cardboard, plastic, glass, and metal. There is a waste storage room and a large number of intermediate collection points distributed through every floor. Respect to construction waste management, the project diverts and/or recycles construction waste through the development of a construction waste management plan with the goal to identify and prevent that these materials go to landfills. Alongside this, the project hired a company responsible for removing construction debris and recycles from site. The amount of recycled or diverted waste reaches more than 75%, attempted 2 points. Use of material with recycled and regional content increases the demand for building materials and building products that incorporate recycled content, reducing impact resulting from the extraction and processing of virgin materials. The project uses material with pre- and post-consumer recycled content, represented at least 20% of the total material cost. The project increases the demand for building materials and products that are extracted and manufactured close to the construction site, supporting the use of regional resources and reduces the environmental impact that occurs when transporting materials from faraway places. The project uses materials that have been extracted and manufactured with a radius of 500 miles from the project. These materials represent at least 30% of the total material cost. Indoor air quality. The strategies to improve the quality of indoor environment have the potential to improve the lives of the building occupants and reduce absenteeism. Strategies that improve the health and productivity of employees over the time have a great return on investment. Moreover, prevention of problems is generally less expensive to deal with than disease and low productivity that results from a low quality of indoor environment. To achieve these goals, attention is required in 2 issues: indoor air quality, thermal, acoustic, and lighting comfort. Points attempted in this category, 7 of 15. Increase ventilation levels. The project exceeds in 30% the minimum levels of outdoor air ventilation indicated by a TRI standard ventilation rate procedure for all occupied spaces in the building. This performance helps improve indoor air quality, contributing to the health, well-being, and comfort of building occupants. In the illustration, you can see the ventilation system design. Environmental tobacco smoke control and CO2 monitoring. Environmental tobacco smoke control. The project minimizes exposure of building occupants, indoor surfaces, and ventilation distribution system to environmental tobacco smoke by prohibiting smoking inside the building and within 25 feet of any building entrance, air intake, and operable windows. Respect to monitoring CO2 indoor concentration, the project has CO2 monitoring system configured to generate an alarm with airflow values or levels of carbon dioxide vary by 10% or more relative to the limit set by design. This is achieved through 2 measures: CO2 sensors in all densely occupied spaces, system for measuring outside airflow into associated injection equipment. Construction indoor air quality management plan before occupancy. Flush-out. A flush-out equal to a complete cleaning of the building contaminants through the injection of 14,000 cubic feet per minute of fresh air per square foot, keeping a relative humidity of 60%. The procedure is implemented using the HVAC system throughout the hamlet units. Controllability of systems. Lighting. A system of high-level lighting control for each occupant or multi-occupied spaces is provided, promoting productivity, comfort, and well-being. The building has 358 workstations with individual lighting, where 327 of them are provided with their own desk lamp. All 127 multi-occupied spaces such as meeting rooms, classrooms, workshops, laboratories have their own lighting controls through a keypad with dimmer that allows various scenes in each space. Innovation in design. Credit address sustainable building expertise, as well as design measures not covered under the 5 lead credit categories. Point attempted 6 to 6. The building as a teaching tool. The building has developed an educational program that includes the following strategies. A comprehensive signage program. Build comprehensive signage program in strategic areas of the building which aims to educate occupants and visitors on the benefits of green buildings. Fact sheet and portfolio of the building. Fact sheet. A brief explanation of the most important sustainability strategies implemented in the building. Portfolio addresses all the prerequisites and credit approached in the building, highlighted the key strategies designed and implemented. Extension program. Educational outreach program that aims to present the project to different groups, schools, universities, specialists, professionals, and so on, promoting the sustainability aspects of the building in the community and showing the most significant aspect of the project. Thank you very much.